Alright, so let's look at today's notes. We're continuing on where it says day 6 at the top of the page. Basically it's 3-1, day 2. We're going to talk about the 5-number summary. So the 5-number summary are the minimum, Q1, the first quartile, the median, sometimes it's called Q2, Q3, which is the third quartile or the upper quartile, and the max. Number 28 says, each of the 5 number breaks up your data into what percents? And the answer is 25%. So if you look at this on a box plot, the min is the beginning point, Q1 is the beginning of the box, Q3 is the end of the box, hence the interquartile range. The median lives somewhere in the box, and then the max goes to the end. So each piece of this is 25% of the data. All right, 29. What is the most common measure of spread we use? The answer is the standard deviation. Okay, so let's talk a little bit about standard deviation. First off, the formula for standard deviation, the symbol is S when you're talking about a sample. It's equal to the square root of 1 over n minus 1 times the sum of each x minus the mean quantity squared. The symbol for the population is sigma, a lowercase sigma, and its interpretation or definition is the average distance in observation. Some definitions will say score. An observation is from the mean. The variance S squared is the symbol for sample variance. Sigma squared is population variance. This is basically just standard deviation squared. It is the average squared distance from the mean. It is also another type of spread. All right, number 30. So we have 3 ways to measure the spread: the standard deviation, the IQR, and the range. Rank them from most resistant to least resistant. So think of outliers and what affects outliers. So let's look at the range first. The range is equal to the max minus the min. So if you have outliers, this would of course greatly increase your range. So this is actually the least resistant. If you're going to have an outlier, it's going to have a direct effect on the range. So then the 2 that we have left are the standard deviation and the interquartile range. So the standard deviation, if you think of the formula, it's the square root of 1 over n minus 1 times the sum of each score. So picture yourself taking an outlier score, subtracting it from the mean, and squaring it. So that would be a pretty big number, right? Because you're still addressing, you still are including the outlier's distance from the mean in your total sum. Whereas with the IQR, it's just Q1 plus Q3 divided by 2. So the outliers don't have this greatest effect. So this is the most resistant. Outliers are going to have the least effect on the IQR, and this is why the IQR is used when you talk about the medians, and this is why the standard deviation is used when you talk about the means, when you do the center of the distribution. So the range is rarely used because it is so greatly affected by outliers. All right, and then number 31. We can now address center with either mean or median, but never use both. When should we use the mean and when should we use the median? So we talked about this Monday in class, but let's go ahead and rehash that. So the mean is when it's symmetric or approximately normal. Single peaked. A better way to say that is approximately normal. Right, and then we use the median anytime that the data is skewed, whether it be skewed to the right or skewed to the left. All right, so that brings us to 32. We can now address spread with either IQR or standard deviation, but never use both. When should we use IQR and when should we use standard deviation? So the IQR is used when the center that addresses the distribution is the median. So if you have a distribution, you've decided that its shape is skewed, therefore the center will be the median, which means that the spread that you'll use is the IQR. So IQR goes with median, or basically skewed data. So if you have a second set of data, you look at the distribution and you find that it's approximately normal, then the center that you would use is the mean, and the spread that you would use is the standard deviation. So the standard deviation is used when the center is the mean. All right, so then on the second one for 33, this is where you're going to look at the separate video for the TI-84. So go ahead and finish this, and then we'll go back to click on the TI-84 video separately. And then TI Inspires, you'll look at your TI Inspire video separately. I know it's kind of a pain in the butt, but at least you'll see how to use your calculator, and you can review this later if you forget. So we'll come back to that in that other video. 34, same way. So that takes us basically to number 35. On number 35, the picture's in the book. It's on page 72, and it's number 96. So you'll want to look at that in your book. Basically, it's talking about the variation or the spread in the stock fund. And if we look at where the smallest part on the stock fund is, it looks kind of like this. It's really long and skinny in your book. And we look at the bottom, if you go across to where it is, it's at about 3.5%. And then if you go across at the top, it's about 3% where the top is. So those are the maxes and the mins. So it varied, right? It had variation. It varied from negative 3.5% to positive 3%. Part B is talking about the medians. So if we go across where the median is on the stock fund, right, we go to where the stock fund's median is, and we go over to see where it is, it's slightly above 0, right? You might put approximately 0. It's a little bit above, so it's actually at 0.1% is the median for the stock fund. It's really kind of hard to tell the median of the other one because it's all squished together. It kind of looks like this. It's actually at 0. So the real estate fund has a median of 0. So they're pretty close. And then part C says, which one's safer, or something along those lines. So basically, if you think of this, if you had money to invest, would you invest it in the stock fund or would you invest it in the real estate fund? Well, it depends on what your goal is. The stock fund has a lot more variability. So you might make a lot, but then again, you might lose a lot. So the stock fund has much more variability. You may gain a lot or you may lose a lot. So basically it's a riskier investment. Whereas the real estate fund isn't going to go either, has a lot smaller variation or variability. So you might make a little money, you might lose a little money, but you're not really gonna go either way, too far in either direction. So it's a much safer investment. Might end up with the same amount of money that you've always had, but you're not going to have the opportunity to make great losses like you might in the stock fund. All right, number 36 is also, we're going to do it by hand first, and then I'll also show you how to do it in the calculator video as well. So first, it talks about the first 4 students to arrive for a first period stats class asked how much sleep to the nearest hour they got each night. So the responses were 7, 7, 9, and 9. So we're going to find the standard deviation using the formula. So standard deviation is equal to the square root of 1 over n minus 1. N is equal to the number, or the total number of pieces of data. So this would be 4 minus 1, right, or otherwise known as 3, times, right? We're not going to put the sum of the symbol because that's what that symbol means. So parentheses, 7 for the first score, minus the mean. So if we look at this, the mean is clearly 8. If you don't believe me, put in your calculator. Plus the second score minus the mean squared, plus the third score minus the mean squared, plus the fourth score minus the mean squared. So all of that together makes what would be our standard deviation. If you put that in your calculator and round to the nearest hundredth, you get 1.15. And these little symbols here mean approximately. So anytime we round, we want to use these little squiggles. So approximately 1.15. Right, and again, I'll show you how to do that in your calculator as well. All right, so let's interpret. So the typical response, so again, tying in the context, the typical response is on average 1.15 hours from the mean response of 8 hours. So basically, it's the average distance from the mean. And so we can't just write it's the average difference from the mean. We have to tie in the context. The typical response is on average. Then we tie in the number from the mean. And then we add the mean's time. And then part C says, do you think it's safe to include that the mean amount of sleep for all 30 students in this class is close to 8 hours? So you might tend to just look at the data and be like, sure, yeah, the mean's 8. But you have to remember, how did you collect the data? And all that you did was stand outside this stats class and you asked the first 4 kids. So you don't have a random sample, you used a convenience sample. So because you gathered the data in a poorly biased manner, your data really doesn't mean anything. So it's not safe to conclude or infer that to the population of the classroom because you did not get a random sample. So the answer is no. This is not a random sample. We cannot infer on the population. So remember, we talked about that at the end of chapter 4. All right, so number 37. It says, do male doctors perform more cesarean sections than female doctors? A study in Switzerland examined the number of cesarean sections performed in a year by samples of male and female doctors. And here's the summary statistics. So that first box above the 41.333 is actually X bar. The second column is S for standard deviation. The third column is min. The fourth column is Q1. The next is median, followed by Q3, and then we have the max and the IQR. So we have a lot of data here we can look at. So if we're looking for part A, the question is, which distribution has more symmetrical shape? So it's kind of hard to see, right? We don't have enough information to be able to just graph the data and look at the entire thing. So what do we know about data when it's symmetric? So one of the things we know is that when it's symmetric, the mean and the median, right? The median and the mean are usually pretty close together. So that's the first thing I'm going to look at. So the mean of the male doctors is 41.333. The median of the male doctors is 34. So that's kind of a wide gap. The females, the mean is 19.1, and the median is 18.5. So based on just that information, because that's really all I can kind of tell, is I'm going to guess that the females have a more symmetrical shape since X bar is equal to 19.1 and median, capital M, is equal to 18.5. Part B is explain how the IQRs of these distribution can be so similar even though the standard deviations are quite different. So if we look at the IQRs, in the top one it's 23 and 19, and then the standard deviations is 20.6 and 10.1. So we're seeing that the spread of the standard deviations has a lot of variability, whereas the spread of the IQR does not. So that's probably indicative of the fact that there's probably some outliers. And that's why the standard deviation is less resistant to outliers than the IQR. So this is indicative of possible outliers. All right, and then part C, does it appear that males perform more C-sections? So if we look at every single one of the male numbers and compared to every single one of the female numbers, you can see that each of the male numbers are actually greater than each of the female numbers. So that does appear that males do perform more C-sections. So yes, because each set of numbers, maybe calculations would be a better word, each set of numbers is larger for the males, right, when you compare the two. Alright, so the question's asking which of the distributions has a larger standard deviation. So again, we want to think about what the standard deviation formula is. So S is equal to the square root of 1 over n minus 1 times the sum of x of I minus the mean quantity squared. So what this is saying is you're taking each piece of data and you're subtracting it from the mean. So if you look at the extremes on variable A, you can see that there's more data in the extremes, which means that more times will you take that big X minus the mean. Whereas if you look at variable B, there's less data in the extremes, so that's less times that you'll have a big number minus the means, or a really small number minus the mean. So the variable B will have a smaller standard deviation. So variable A will have a larger standard deviation. Alright, so then let's look at kind of this review part at the bottom where we talk about the conclusion. We're really at the end of the chapter. The most important part of chapter 1 is describing and comparing So that's univariate distributions. You need to address all four components of SOX, so shape, outlier, center, spread. But you first need to know the type of data, right? Whether it's going to be categorical or whether it is quantitative, because that depends on what type of graph you're going to make. So now in the shape, the components, and then symmetrical looks like this, and then skewed, we've got where the data is kind of all clumped up on one side or all clumped up on the other side. All right, for the outliers, the two formulas are Q1 minus 1.5 times IQR, Q3 plus 1.5 times IQR. The center, when the distribution is symmetrical, it's X bar. When the distribution is skewed, it's the median. The spread, when the distribution is symmetrical, it's the standard deviation. And when it's skewed, it's IQR. So this is the most important thing to come out of this chapter. All right? So then, also at the end, they say when comparing two distributions, it's not enough just to state SOX for both distributions. You must compare. So you need to make sure that you use the words like greater than, less than. The mean of distribution A is greater than the mean of distribution B. The standard deviation of distribution A is smaller than the standard deviation of distribution B. So you have to use those comparison words. Otherwise, they will not give you full points on the AP test. All right, that's our notes for tonight, and we will go over practice problems tomorrow in class. And don't forget to watch the calculator videos for each of your calculators.